Alright, this video is on limiting reactants and theoretical yield. Just a couple quick definitions. Limiting reactant is the reactant that is completely used up during the course of a reaction. And theoretical yield is the stoichiometric amount of a given product that can be produced by a reaction. Now, we have to toss off a misconception that many of you may be wondering about. Is here's substance A and substance B, and it's going to form substance AB in this synthesis reaction. Okay? Now, the chances of there being the exact amount of A and the exact amount of B, that all of it would form just AB and there would be nothing left over on the reactant side, is highly unlikely. Okay? Usually, there's one substance that is in excess, and there is, which is known as the excess reactant, and then there is one substance that is usually used up and runs out of it, and that is called the limiting reactant. Okay, so in real life, okay, we don't normally have both reactants. The amounts that are given in a specific situation are all going to be used up. Usually, one of them is in excess, the other one is a limiting reactant. Now, theoretical yield, what that means is, let's say A is our limiting reactant and B is our excess reactant. Well, the amount of AB that I can make based on the given amounts of my limiting reactant, that is my theoretical yield. Okay, and we'll do a couple problems right here. So for time's sake, I went ahead and gave you the equation, and it's already balanced for us. Okay, so what would be the limiting reactant if 36.8 grams of nitric acid were reacted with 6.72 grams of nitrogen monoxide? Okay, so what you have to do is, here I'm given two different masses, and I want to find out which one would be my limiting reactant. Okay, so I'm going to go ahead and just, when you have the option to just pick one of the products, because it doesn't matter which product I make right here, I just need to find out which one's going to, which one I want to make. So I'm going to go ahead and go with water. Okay, and what I want to do with trying to find out the limiting reactant, I want to find out which one of these, either this 36.8 grams of nitric acid or this 6.72 grams of nitrogen monoxide, is going to make the least amount of water. And what I mean by that is, it's going to run out first. Whichever one of these reactants right here that runs out first is my limiting reactant. And what I'll do is I'll just do a mass to mole relationship using molar mass and molar ratio. Okay, so what I want to do is I'm going to end up doing two different problems here. I'm going to go from grams of NO to, now I can go all the way to moles, or I can go all the way to grams to find out how many grams of water I can make, but I'm just going to go to moles of water. Right? That's that's one reaction. And then the other reaction is going to be grams of the nitric acid into moles of water. Remember, I just chose water here. You could have chose nitrogen dioxide. It would have worked the same. Okay? So the process is not changing here. Okay? So just look at my literature values to get my molar masses. Okay, so look at the molar masses of NO and HNO3. So there's my molar masses. I'll need to use those here first. So I'm going to start with what I'm given. I'm given 6.72 grams of NO. I put that over 1. And then I'm going to use molar mass, which is 30.01 grams of NO for every 1 mole of NO. And then I'm going to go from moles of NO to moles of water. Well, it happens to be a 1-to-1 ratio. 1 mole NO, 1 mole H2O. So when I do my math, I end up with 0.224 moles of water. Okay, now I'm not done yet. All I did was find out if I had 6.72 grams of NO, how many moles of water I can make. Okay, next I'm going to go do the same process but with the nitric acid. So I started off with 36.8 grams of nitric acid. Put that over 1. And I have my molar mass of nitric acid is 63.02 grams of nitric acid for every 1 mole of nitric acid. Use molar ratio. In this case, the molar ratio would be 2 moles of nitric acid for every 1 mole of water. So when I do my math, I end up with 0.29, I need 3 sig figs, 2 moles of water. Now, analysis, what does this mean? This means if I mixed up 36.8 grams of nitric acid and reacted it with 6.72 grams of NO, nitrogen monoxide, I would end up making a certain amount of water. Okay, and I just chose water. Like I said, you could have done the same thing but used nitrogen dioxide, used the other product. Okay, so I found out how much water can I make with the 6.72 grams of nitrogen monoxide, and I found out I can make 0.224 moles of water. And then I did the same exact process again, but I used the 36.8 grams of nitric acid to find out how much water I can make with this much nitric acid. Well, as it turns out, I'm able to make more water with that amount of nitric acid. But the thing is, if I had that amount of nitric acid, I would run out of that reactant. I can't make that much. This amount of nitric acid right here can only make 0.224 moles of water. It cannot make more than that. So this down here, okay, I'm not going to be able to make this with these amounts of the reactants, okay, because I won't have enough nitrogen monoxide to make that much water. So this right here is how much water I can make, how many moles of water I can make, okay? And because the lesser amount of the product being made is based on the nitrogen monoxide is our limiting reactant, okay? Now, from there, I can do a theoretical yield, okay, which is simply taking that amount of moles of water that I'm able to make, and I put it over 1, and I want to find out how many grams of water I can make. Well, 1 mole of water makes 18.02 grams, or is 18.02 grams of water, which means my moles cancel out. My final answer is 4 point, with 3 sig figs, 4.04 grams of H2O. That is my theoretical yield. That's as much water I can make in grams. Okay? So, let's do another one. Okay? So actually, I'm going to look at limiting reactant. I want to find the limiting, it says reagent. Reactant, reagent roughly mean the same thing. Okay? A reagent is all of these guys right here. They're all reagents in the reaction. I use the word species. Okay? But when I look for a limiting reagent, I'm mainly looking at these two species because those are the reactants, and it's the reactants are what limit it. The product is not a limiting reagent. It's usually, it is a reactant. Okay? So, what would be the limiting reactant if 93.1 grams of aluminum were reacted with 231 grams of hydrochloric acid? Okay, and let's go ahead and pause it and clean things up. Alright, just to save some time, I already have the problem worked out. I'm just going to walk you through what I did. Okay, I need to find the limiting reactant. I just picked a product. I picked hydrogen gas. Okay, so I start off with 93.1 grams of aluminum, right? And I use molar mass to find out how many moles of aluminum, and then I'm going to use the molar ratio. Okay, so here's my molar mass, then my molar ratio, and then I use my molar ratios based on my stoichiometric amounts in my balanced chemical equation. And then I end up with making 5.17 moles of H2, which means 93.1 grams of aluminum can make or produce 5.17 moles of hydrogen gas. Okay? Now that I know that, I need to look at the other reactant. So 231 grams of hydrochloric acid, and then I'll use molar mass again to find out how many moles of hydrochloric acid. And then I will use molar ratio right here to get to moles of hydrogen gas. I do my math, I end up with 3.17 moles of hydrogen gas. Okay? Because the hydrochloric acid, the amount of hydrochloric acid that was given makes less product. Okay? That means the hydrochloric acid is my limiting reactant, and my aluminum is my excess reactant. Now, the reason why I chose these two problems, if you look at this one, okay, the lesser amount, the 6.72 grams, ended up being the limiting reactant. So if you think, well, there's less NO than there is HNO3, that must be limiting reactant. Well, in this case, it happened to be that way. In this case here, I had 93.1 grams of aluminum, but I'm going to end up with that much, I'm going to have left over. Okay, the 231 grams of hydrochloric acid is all going to be used up. Okay, so don't look at the amount of the grams and go, okay, the lower amount is the limiting reactant, because that's not true. All right, so if I was to do the theoretical yield for this, I would go 3.17 moles of H2, okay, because I use the amount that is produced by the limiting reactant, number of moles, and then 1 mole of H2 is 2.02 grams of H2. I do my math, I end up with 6.40 grams of H2. And that's my theoretical yield. Okay, this is theoretical yield. All right, and which makes this my limiting reactant. This is my excess reactant. Okay, the type of questions you'll get on your worksheet will be identify the limiting reactant, identify the excess reactant, what's the theoretical yield of a certain product. Okay, now here's the thing, a little helpful hint. If I say, let's go ahead and jump ahead real quick. Okay, if I was to give you this equation right here and I said, identify the limiting reactant, identify the excess reactant, and identify the theoretical yield of zinc. Now, identify the theoretical yield of zinc, that should help you a little bit, because when you're finding out the amount, or say, obviously I don't have any masses right here, I'm just doing this as an example, but if this is, say, the limiting reactant and this is the excess reactant, okay, when you're finding that out and finding out which one's limiting reactant, use this as your product, because you got to find out the theoretical yield anyways.